Chapter 4, Congruent Triangles, Section 1, Congruent Figures. Starting with a few definitions. So congruent figures have the same size and the same shape. So you can't have a square that's congruent to a triangle. They have to have the same shape and they also have to be the same size. Now a polygon is a closed figure made up of straight lines which do not overlap. So this is where we say that a circle is not a polygon because it's not made up of straight lines. A polygon has to be made up of straight lines that do not overlap. So that would be a polygon, but this would not be a polygon because the lines are overlapping. So just a few examples there. Now when looking at congruent polygons, their corresponding parts, meaning their matching sides and their matching angles, are congruent. So if I tell you that these two figures are congruent, let's say quadrilateral ABCD and quadrilateral EFGH. If I tell you that they're congruent to each other, that means that the corresponding pieces are congruent. So we have, if we're looking at this as the top, BC is congruent to, even though it's flipped around, HG. AD is congruent to EF. And then you have to start to look at angle measures a little bit. So we can see that CP, when you turn this figure around, because that's what happened here, CP would be congruent to EH, and AB would be congruent to FG. Then looking at the angles, we could say that angle ABC would be congruent when we turn it around to angle G, which means angle BCD and GHE are congruent, and so on and so forth. So this angle would be congruent to this angle, and this angle gets a little sloppy after a while, but you need to use more symbols when they're not congruent to the first angle. So in other words, ABC isn't the same thing as DAB, so we need to show that they're different, but they're congruent to corresponding parts on the other. So you can see that any rigid motions are transformations that don't change the size and the shape. So the only transformation that would change the size and the shape would be a dilation. So in this case, this would be a slide, so a translation, and it would probably be a flip or some sort of turn, but they're all rigid transformations which keep the figure, the original, is congruent to the new. Theorem 4.1, the third angles theorem, states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So if I tell you that the measure of this angle is 40 degrees, and the measure of this angle is 60 degrees, and then I have the same thing here. This is my 40 degrees, and this is my 60 degrees. Well, we know that the third measure of the triangle must then be 80 degrees. And if the first two angles are congruent in triangle 1 and in triangle 2, then this third angle must also be congruent, so it must be 80 degrees. So if you have any two triangles where two angles are congruent, that means that the third angle must also be congruent.